now turn to Section 4. Section 4. You will hear part of an agricultural lecture on the use of the global positioning system in today's agricultural industry. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Hello everyone and welcome to this agriculture lecture. Today we're going to look at the increasingly important role of the global positioning system in our current agriculture industry. The development and implementation of precise agriculture or site-specific farming has been made possible by combining the global positioning system, known as GPS, and geographic information systems, known as GIS. These technologies have enabled the coupling of real-time data with accurate position information and have led to the efficient manipulation and analysis of large amounts of geospatial data. GPS-based applications in precision farming are being used for farm planning, field mapping, soil sampling, tractor guidance, crop scouting, variable rate applications, and yield mapping. GPS also allows farmers to work during low visibility conditions such as rain, dust, fog, and darkness. In the past, it was difficult for farmers to correlate production techniques and crop yields with land variability. This limited their ability to develop the most effective soil or plant treatment strategies that could have enhanced their production. Today, more precise application of pesticides, herbicides, and fertilizers, as well as better control of the dispersion of these chemicals, is possible through precision agriculture. This results in a reduction of expenses, producing higher yields, and creating a farm that is more environmentally friendly. Precision agriculture is now changing the way farmers and agribusinesses view the land from which they reap their profits. Precision agriculture is about collecting timely geospatial information on soil, plant, animal requirements and prescribing and applying site-specific treatments to increase agricultural production and protect the environment. Where farmers may have once treated their fields uniformly, they are now seeing benefits from micromanaging their fields. Precision agriculture is gaining in popularity, largely due to the introduction of tools into the agricultural community that are more accurate, cost-effective, and user-friendly. Many of the new innovations rely on the integration of onboard computers, data collection sensors, and GPS time and position reference systems. Many believe that the benefits of precision agriculture can only be realized on large farms with significant capital investment and experience with information technologies. This is not the case. There are inexpensive and easy-to-use methods and techniques that can be developed for use by all farmers. Through the use of GPS and GIS, information needed for improving land and water use can be collected. Farmers can achieve additional benefits by combining better utilization of fertilizers and other soil amendments, determining the economic threshold for treating pest and weed infestations, and protecting the natural resources for future use. GPS equipment manufacturers have developed several tools to help farmers and agribusinesses become more productive and efficient in their precision farming activities. Today, many farmers use GPS-derived products to enhance operations in their farming businesses. Location information is collected by GPS receivers for mapping field boundaries, roads, irrigation systems, and problem areas in crops such as weeds or disease. In addition, the accuracy of GPS allows farmers to know precise acreage for field areas, road locations, and distances between points of interest, and it allows the farmers to create farm maps with all this information. GPS allows farmers to accurately navigate to specific locations in the field, year after year, to collect soil samples or monitor crop conditions. Farmers and agriculture service providers can expect even further improvements as GPS continues to experience modernisation. In addition to the current civilian service provided by GPS, Australia is committed to implementing a second and a third civil signal on GPS satellites. The first satellite with the second civilian signal was launched 10 years ago. The new signals will enhance both the quality and efficiency of agricultural operations in the future. Very high GPS accuracy can be achieved. However, for real-time applications that require on-the-go adjustments, a variance GPS is preferred. A straightforward manner of accomplishing this is to use two GPS receivers, known as a rover station on, for example, a tractor, and a fixed base station, which track the same satellites so that many of the areas can be minimized and higher accuracy can be obtained in real time. Since the position of the base station is known accurately, the error in estimating the location of the base station using satellite signals can be determined. This differential correction can be communicated to the field GPS receiver in the rover by a radio link, and this information can be used to increase its accuracy. The deployment of two GPS receivers for agricultural applications could, however, be expensive in many instances. An alternative to reduce the cost without degrading the positional accuracy is to use one of the available correction services. If the GPS users obtain one of these available services, only one receiver can be used as a rover and no base receiver would be required.
That is the end of Section 4. You will now have half a minute to check your answers.